everybody, I'm Brian, and today we are going to get into a topic that I got requested quite a little while ago. It's called Multicast. Multicast. Tell you what, stick around and we'll get into it. So, what's the deal with multicast? Well, first, let's take a second to talk about normal traffic that's not multicast. So normal traffic might be if I send a message to you, right? If my computer sends a message from its IP, its MAC address, to your computer from the same network, your IP, your MAC address, that would be unicast traffic. One source, one destination. Okay, that works, right? That'd be great if I send a big file or something over to you. Or maybe there's another sort of normal traffic called broadcast. Broadcast is a shout to everybody in the network, the broadcast domain. That might be because your computer needs an IP address. And so it sends out a shouted broadcast to everyone in your network that's a DHCP request. And assuming at your house there's a DHCP server to hear it on that same network, it'll hear that broadcast and respond back, and now you get an address. Okay, so that's unicast and broadcast. These are sort of normal types, I would say, of network traffic. Multicast is somewhere in between. Multicast would be like your computer sending a message out from its IP address, from its MAC address, but to a group address instead. A multicast is one source with a group as the destination. Tell you what, though, to make a little more sense of that, I think it's time for Tiny Brian. Hello. Okay, and hey, we got paint ready to go. Let's draw. So what we want to do is let's jump straight to what the heck this might be for. So let's say you're wandering around the concert hall or whatever, right? The local venue where you're going to go see some awesome show. Electric Callboy came to town, or Baby Metal, or some other awesome band. And as you're walking around outside, you see all those TVs around. And on those TVs around in the hallway, they've got advertisements on them for the truck rally this Sunday. Or Domingo, I don't know. Or that some other band is coming in a month or two, right? Just as you're walking around, you see all these things, and they're all changing at the same time. Well, how do the TVs do that, right? There's not a TV station just for shows coming to your local event center. Not exactly. But on the back of all of those TVs, there's going to be some little gadget. Let me just label these. Okay, so there's some little gadget that's on the back of all of those. And it's got one video cable connecting up to the TV, and then it's got one network cable that's attaching it up to some network switch. Now, let's just make some copies of these. Yeah. So there's some network switch out there. Sure, why not? Doesn't exactly fit. And these are all connected up to it over Ethernet. And what's happening is that off in some back office, there's going to be oh my God, some old Dell or HP or whatever in some back office computer. In some back office, there's this computer that's probably from 2011 or something like that. And it's just some PC. And effectively, it's running a slideshow on it, probably just PowerPoint or something like that, where they've just typed in and dropped the pictures into it. But there's some extra little bit of software on there as well that's just taking whatever's on the screen and it's sending it out from that computer's Mac, whatever it is. I don't know. Maybe it's got, different color. Maybe it's got a MAC address of A. Right, it's actually 12 characters, whatever. Let's just lie and say it's A. And say it's got some IP address of, doesn't matter, 10.10.10.10. Okay, well, it's going to be sending out this video stream over that same network, and it's going to send it from its IP address out to all of those receivers. Now, it could be done with unicast. Unicast is one source, one destination, but if we were doing that, then that would mean that all of these receivers would, well, they're going to have their own IP and their own MAC, but it would be sending a copy of that video to the first TV and the second TV and the third TV, and there's probably like 50 or 100 of those things all over the place. So that's going to be a whole lot of streams of video. And if that was what we're doing, if we were using Unicast, so let's go big-ish for the moment, and let's say it's a 100 megabit per second video. It's not going to be that high quality, but let's just lie and say it's 100 megabit per second video. Okay, great. Well then, to one TV, it would be 100 megabit per second. To 3 TVs, 300 megabit per second. To 10 TVs, 1,000 megabit per second. Oops, that's gigabit. Right? How are we going to do our like 100 different TVs that we're sending this all out to? Okay, now I've exaggerated. It's not actually going to be 100 megabit per second. That'd be kind of crazy. But still, if you are using Unicast, one source, one destination, then that is going to eat up significantly, or rather a significant amount of bandwidth, because every time you add a new sender, or a new receiver rather, then that's going to be that much more bandwidth you're eating up. And that computer itself is going to be processing one of these streams each, right? So that's going to take more of its more processing power on it, right? And so now this real old computer, we might be having some trouble. So instead, we do this multicast thing we're talking about, this send to a group address. And now we're going to send out a stream of video, a whole bunch of packets that are chunks of data to send out for this video. And one copy of it, as in like, you know, we're just constantly sending out one stream of data from us, but now to some destination address that's a group, right? So I'm going to go and just line, or not to explain it, and I'll say it's from our 10.10.10.10 to 239, actually, hang on, to 239.10.10.10 is our destination address. What? Well, that looks like a different network. Don't worry about it. Multicast. It's a little bit weird. This isn't actually to a different network. But now it would be from our 10.10.10.10 to 239.10.10.10. The end doesn't have to match up. I just did that to make it easy. And then on the back of these little gadgets, on the back of all those TVs, these little multicast receivers, you would essentially have them be configured to be listening in on our 239.10.10.10. Each of them would essentially be opting in, saying, hey, if any traffic shows up to that destination address, I want to listen. I want a copy of that. So anything destined to that, they're looking for it. And so now, one copy of the message goes out. It hits that switch. The switch, if it sees multicast traffic and you haven't done anything at all, any switch I know of, we'll just treat it like a broadcast and dump it out every other port except the one it came in on, by default. You can configure it so it only sends it out the right port, but that's a whole other thing. For the moment, we're just saying, by default, any switch will just treat it like a broadcast, send it out every port but the one it came in on. And all of those computers out there will be looking for traffic on this same multicast destination address, 239.10.10.10. And so when they receive that, they'll say, oh, sweet, that's for me. And now it plays on the TV. Why do we have this address thing at all when it could just be a broadcast? Well, what if half the TVs are doing one thing and the other half are doing something else? What if I have 2 different streams? What? Yeah, why not, right? Like, maybe there's some TVs that are like up more the more expensive seats, and we're like, I know, for them we're going to advertise the more expensive shows that are coming up, right? Like, so we can kind of tweak it to have different parts of the place show different things, right? Or maybe we have some of them, like every other one is showing something a little bit different, like, hey, show starts in 10 minutes with a countdown or something like that, but it's only every other one. We could do that. It's just that we would have now a second multicast address, right? So all those ones that are doing the different thing, well, sure, they're on 239.10.10.20. And it can just be that some of the TVs are instead tuned to, basically, right, programmed to listen in, oops, to that different address, 239.10.10.20. Well, cool. Now, even if the switch is just dumping all this traffic out every port, and we got these 2 different streams going out about all the ports, well, any of the multicast receivers set to 10.10.10, or 239.10.10.10, they're only going to listen to, only see and show the multicast that's being sent out to on that address. And the TV that's not set to that one, that's set to 239.10.10.20, the gadget on the back, well, sweet. It's going to ignore the other one, the 10.10.10 one, but it's going to now just play that one video that's 239.10.10.20. Multicast. Yeah! This is the idea of a multicast group. Receivers can effectively opt in to say, this is the one I want. Now, a little bit about that switch. If this was a little bit of a nicer switch and it was configurable for multicast, then we could, and we'll get way more into this in another video because I want to keep this one not without being too crazy long, but we could set up something called IGMP, for IPv4 anyway, to make the switch pay attention. And then it could say, hey, there's these multicasts showing up. And it could look for who joined into a multicast or who said they didn't want to copy anymore, leave. And it could only send the multicast to the ports that the join came in on for that particular multicast. I'm just barely touching on that for the moment, though. You could do that. For the moment, we're just going to say it's not configured at all, and it's just flooding it all everywhere. And the individual receivers are just opting in to only caring about one or another. Okay. How else might you use this? In fact, in that same cool venue, it might be that the lights that are hooked up to the big light board might also be using multicast. What? Yes. In fact, the first case I ever had with multicast years and years ago was exactly that. It was that basically they're having a little bit of trouble, but their lighting board used Ethernet to communicate with the different lights in their grid, because there are all these different, it's not necessarily just red light turn on, red light turn off. Certainly could be, right? But there's a lot of computerized, and has been for quite some time, lights with sophisticated controls. And if you're using Ethernet to communicate with that lighting information, well, yeah, each of those different lights or chunks of the light in the grid might be set to different multicast addresses, so that as that lighting board sends out the message to, like spin over here, go up like this, be green, be red, be orange, whatever else, it's sending it out to a particular multicast address. And so even if the switch was flooding it to everybody, all the other ones that aren't on that address, well, they're just going to ignore those, right? And so in this way, it can be used for multicast to be able to control complex lights as well. It's not the only way for sure, but yeah. And again, there different multicast addresses would be used for different receivers, so that the commands could be sent, not just the appropriate commands out of that lighting board, but just to the correct address for the one or multiple, right? Because maybe it's a whole bank of them that need to do the exact same thing, lights. Okay. Multicast. There's many other examples. Hold music in voice over IP. A PA system, like, as you're walking around for like background music. Very often, these are also based on multicast. One sender to multiple destinations. Whoa. Okay. A little bit more. What I want to do is I want to talk about that multicast address. And link to old video. There's a range of IPv4 addresses and a range of IPv6 addresses, but I don't want to scare you, that are reserved just for these destination-only addresses. Yeah. I'm just going to recycle this. Hang on, let me change my size here. Okay, so for, make it more obvious. For IPv4 multicast, any address, the IPv4 address, right, 4 outlets, that starts somewhere between 224.something.something through 239.255.255.255, that is the IPv4 multicast range. These addresses are not allowed to be used by your NIC, my NIC, anybody's NIC, as their own address. No computer can say that is my address, because those are reserved for multicast. They are destination only. You can only send to them, not from them. Yeah. And kind of odd, but a whole bunch of this range, in fact, the vast majority of this range is reserved. Yeah, anything starting with 224 is basically like protocol stuff. There's a big chunk in there that's designed for multicast on the internet. It's not really a thing. I mean, kind of, sort of, but it's not really a thing, as it's turned out. But in fact, the addresses starting with 239 are the ones for me and you and your business and my business. 239 dot something dot something dot something is multicast user traffic, stuff that you're going to do yourself. There's a couple in there that are actually reserved for one protocol or another, but let's not worry too much about it. Basically, that whole range, that whole /8 of 239, that's something you can use, right? So our 239.10.10.10 or 10.10.20, yeah, those are both IPv4 multicast addresses. And because this destination range somewhere between 224 and 239, right? Our destination addresses for multicast. Well, inherently then, you're not going to have your own computer that's sending traffic look like they're in the same network as those, right? Like your computer at home is probably 192.168.something, or at the office is 10.10.10, well, 10.something.something.something, right? But your computer can send out a multicast. It's just going to send from its own IPv4 address to whatever destination address, like 239.10.10.10. Yeah, okay. So that's why before, when you were talking about it, don't worry about it, looks like it's in a different network. It's going to be in the same network here. Okay, cool. Okay, touch on IPv6. For IPv6, it's going to be anything that starts with FF is the IPv6 multicast range. FF02 is sort of the equivalent of 224. That's a whole bunch of protocol stuff, like OSPF v3, whole bunch of stuff to do with ICPv6. Any kind of like protocol stuff is going to be FF02 for their built-in multicast thing. FF05 is sort of our equivalent of 239. If you're using IPv6, cool, love it. And if on top of that using IPv6, you're actually setting up your own multicast, a rarefied breed, you are very fancy. Probably it's going to be FF05 : blah blah blah, and then I don't know, maybe end it with like 2, right? Maybe it's because there's 8 different of those hextets, right? So you could have FF05 : and then do a giant big address if you really wanted, but probably not gonna. All right, so that's sort of the equivalent for IPv6. Same rules there for multicast. You're going to send it from your own IPv6 address to that destination IPv6 multicast address that's on your lighting board or the back of your TV, if that's what you're doing. Okay, so let's see where we're at. We have talked about this idea of multicast traffic, one source to a group destination. Yeah. We've talked about this idea of the destination address is going to be in the multicast range. IPv4, technically 224 through 239. IPv6, technically anything that starts FF, but FF05 is probably what you're using. The same way that it's 239.something.something.something is probably what you're using for IPv4. We talked about this, whatever devices are receiving the traffic are literally going to be set up for that. For those gadgets on the back of the TV, there's a decent chance that there's like, if you bought it a long time ago, maybe dip switches, or maybe even like a dial or something like that. And there's probably like just a handful of options that you have, and you check the manual and it's like, look, use one of these like 5 or 6 or whatever IPv4 multicast addresses, and you just make sure your software is sending to the right one. Okay. If it's a software solution, then hey, you can just configure the whole darn thing yourself. What else? Oh, yeah. I just wanted to shout out a friend. So, Dot, if you're out there, basically a friend over in the Tech Dweeb Discord, sat down with me and did kind of a gut check with me, make sure I was still on the right track and things hadn't changed too much as far as the entertainment side of things and how multicast is getting used. So he called out a few things that might be useful out there as well. I'll drop it in the chat here. I'm sorry, the chat. What am I saying? I'll drop it in the description as well. So yeah, just some good resources, and I'll put these down in the description. For instance, here we go, MC Hammer. This is one that I've used in the past, and conveniently Dotted run into this as well. Just a good tool to be able to test your multicast configuration. All right, hey, let's go big. Ah, look at me, I'm giant. Hey, y'all, I'm having a blast, and I hope you are too. Yeah, I'm gonna keep coming back, absolutely, but like, we'll play it by ear, right? Like, I wanna try and balance life with this awesome hobby and hanging out with you. So, do me a favor, let me know down in the comments if there's something you want to make sure I get to cover, and hey, say hi if you get a sec. I'll be down in the comments hanging out and saying hi right back at you. We'll see y'all next time. Jean-Baptiste Emmanuel Zorg. Multicast.